So our next panel is Cryptography's Best Move. We have moderator Joshua Topkin, and I'd like to invite everyone up to the stage, Josh, Kostas, and Dr. Kate, and I'll let Josh take it off and intro everyone personally.
All right, I hope my audio is coming through. That was a great panel, Cheyenne. Thank you so much. As we all know, Movelang is very promising. Of course, we have Solidity, we have Rust, but kind of the new kid on the block is the Movelang, and there's so many promising things. As the folks that are into Move know, that this is a much safer smart contract language, much easier for developers to not make mistakes, right? So, and that's really important for the industry in order for us to kind of move forward. So my name is Joshua Topkin. I'm the co-founder and CEO of Supra Oracles. I have the absolute pleasure to introduce two absolute gigabrains, Dr. Kostas Kalkias of Missing Labs and Supra's own Dr. Annika Kate. So let me do some quick introductions and we'll get started here. So Kostas is an applied cryptographer, having led the crypto and security teams of at least 3 blockchains: R3 Coda, Facebook's or Meta's Libra project, and now Sui as a co-founder of Missing Labs. His work expands in ZKPs, time capsule encryption, solvency proofs, and optimized BLS, ED, DFA signatures, occasionally a white hat hacker, having found serious vulnerabilities in many crypto systems and smart contracts in the past. Dr. Annika Kate brings 15 years of research experience in applied cryptography, distributed systems, and digital privacy at Supra. He has been actively working on blockchains for the last 10 years. His high-impact projects include KZG polynomial commitments. In the Ethereum world, you all might know KZG commitments or Kate commitments. That was Dr. Kate's invention. He's also involved in partially synchronous DKG, distributed key generation, layer 1, layer 2 transaction privacy, and of course, randomness by distributed oracles. So welcome to the MoveCon. This is a very exciting opportunity for me personally. I do get a wonderful chance to work with Dr. Kate closely, but I've been following Crypto Kostas, or we also like to call him Cryptos, his work as well, and it's a wonderful time to be here. So let's jump into this. We have some really wonderful questions to jump into this first, and the first one we have is, what is the current status of cryptography for blockchain? Where are we as a community, and what are the most interesting primitives from your points of view? Maybe we can start with Kostas.
Yeah, thanks for the introduction, Joshua, and good to see you again, Anket. By the way, we had this discussion like on the very early days, like after Bitcoin. Imagine we started just with a signature. You need the signature protocol and you need the hash function, of course. But then down the road, we realized after 2016, especially after like the Ethereum smart contract language coming there, and some permission blockchains originally from IPM, like the Corda one that I worked like originally, and then all of them like L1s, L2s popping up into like offering some new features. What changed completely was even the career path of a cryptographer. Like I remember most of us actually started with PhDs and everything. Probably our best option was to be like probably an academic somewhere, right? And we didn't have many options. However, we realized that it's not only signatures and hash functions, right? Imagine we have Aniket here who created a new kind of accumulation, right? And previously we only knew about Merkle trees. And then out of a sudden, suddenly we found like a way to have all one commitments, like you just push one single piece of data, and then eventually you can verify that something is included in some group, like a membership proof, which is very, very fast. This is very useful, right? So we have new commitment schemes and new accumulator schemes that are very important for many operations in the blockchain. I will leave this topic to Aniket, and then I can get back the pass to talk about zero knowledge proofs and other quick information that you might want to know. Aniket, I leave this topic for you because you are the expert here, right? The inventor of all of this cool technology.
Thank you. Yeah, so I guess I did not prepare to talk about that. Just kidding. So indeed, I guess what we started to observe that it is possible, especially for the proof from the proof perspective, the knowledge proof perspective, that we can make them extremely succinct and still try to maintain the universality, different approach. And there's a significant growth that's happening in this space. So I can certainly say that the zero knowledge proofs are prevalent and are continue to remain prevalent. It's certainly a major shift in last 2 to 3 years that we started to see a huge effort that's happening there. And indeed, KZG is one part of it, but there's a huge effort that's happening in all sort of different mechanisms that could be applicable and employed there. And in fact, you can say that there are every 6 months we have a new cool kid on the horizon. And not only they just are theoretical, people already go ahead and implement it. So it's very nice. And also when I hear from Costa that they are always upfront on that and they want to make sure that that's available with the SUI move, it's certainly the extremely win-win situation, because rather than relying on some off-chain mechanisms, you can just do that at the layer 1 itself. Along with that, I want to add a couple more things. Moving forward more is that from the perspective going forward, I guess the multi-party computation, threshold cryptography, as well as things such as VDF for verifiable delay functions kind of technologies could also have very interesting impact on some of the solutions that we're working on. But indeed, as Costa already mentioned, zero-knowledge proofs are certainly something the most exciting talk these days. Yeah, Costa.
Exactly, and it's not only zero-knowledge proofs, right? I mean, you mentioned threshold cryptography now, and at the same time, we have like all of these requirements, especially on the wallet side, where people want to share their secrets to different parties. And then again, you need some MPC, you need some threshold cryptography as well. So we have zero-knowledge proofs. We have obviously like optimizations on the signature schemes. We have very fast hash functions. Some of them have to be zero-knowledge proof friendly, because the hash function is everywhere, right? It's not only the conventional functions we know like SHA-2, SHA-3, make Blake, but there are also like Pedersen hashes. There are like Poseidon. There is like the rescue hash function. There are many new hash functions happening in the space that are very useful. And at the same time, I will add a few more like concrete applications that might use in the background, like MPC or zero-knowledge proofs. It's anonymous credentials, right? It's very, very important, like primitive for especially KYC, and regulation is coming, and we will see a lot of cases where the anonymous credentials are very important. Inside these, there is like development in cryptography to have like some kind of trapdoor in case of an investigation. There are some situations where you have to like combine this with like some tracing if something bad happens on chain, and then you need to find who is actually responsible for some fraud happening. And at the same time, there is also a very interesting topic that we will discuss today, randomness on the blockchain, right? It's something that we will see coming more and more, especially with a protocol like SUI, that we actually advertise all of these high frequency blockchain transactions per second, and at the same time very, very low latency. Having like a method to provide randomness very quickly to all of these gaming applications that will probably jump into one of these high frequency blockchains is one, like, you need to create new protocols here to be able to accommodate all of this traffic and requirements, right? And there is more under this, right? There is also like a part of cryptography that is like focusing VTF, you mentioned verifiable delayed functions, that can also be used for randomness, by the way, apart from all of the other things that we do. And there is also cool technology like using all of these primitives for e-voting. E-voting relies a lot on some cryptographic primitives. There is also sealed bit auctions. And with auctions, we can even have like time capsule encryption and all of these like schemes that you didn't expect that they even exist, but the blockchain make them a reality. And I can give you some hints in the past. Before the blockchain space, I used to work like with governments and actually even advising a few operators out there. They didn't even expect there will be like down the future some like public bulletin board where all of these functions, either by oracles like the Supra oracles or by the L1 like blockchains, will be available for non-technical people. And this is, I think, the bet we had in the last few years. The blockchain helped a lot on the evolution of cryptography in general. And I believe this is because there was a new ecosystem of startups. Obviously, the money was flowing much easier for innovation. And this was an obstacle in the past. Imagine that in the past, it was only NSA and NIST providing new standards into the space, right? And now we have community proposing new schemes, and then people are betting, are actually making auctions, are voting over the next standard, which makes decentralization even better and the proposition of new ideas a lot easier now.
Yeah, thank you for that, Kostas.